All right, let's get started. Hi, everyone. Good afternoon. Thanks for coming. My name is Joe Marini. This is upgrading to a Chrome packaged app. I'm a developer advocate here on the Google Chrome team. You can see I've used my considerable clout within Google to get the highly sought after end of the day slot. But thanks all for coming. So before I get started, let me do the obligatory survey. How many people have heard of Chrome packaged apps before? Wow, that's amazing. Everybody. Wow, OK. All right, thanks very much. Good night. Hey. All right. Can you guys hear me OK? Volume all right? All right. One of the great things about being a New Yorker, no one ever says, hey, Joe, can you speak up? All right, so here's what we're going to talk about today. I'm going to talk about why would you want to build a packaged app? What are packaged apps all about? How many people saw Eric Kai's session yesterday on the State of the Nation? OK, not everybody, OK, but some of you. All right. So in that case, I'll go over some interesting demos as well. So I'll talk about the structure of a packaged app, why you'd want to do this. But most importantly, what I want to cover in this session is the issues that you're probably going to face when you take an existing web app and go to make a packaged app out of it. So let's go ahead and get started. And by get started, I mean let's take a look at some cool demos. So if you, now that you guys have pixels, if you set it to be on the dev channel, you can go to the Chrome Web Store. How many people have gone to the Chrome Web Store in the past to get stuff? OK, we lost a few. All right. There's this thing called the Chrome Web Store. And in your Pixel, when you go to the app launcher, there's an icon there. It says Chrome Web Store. And that means store. They just couldn't fit it all on one line. But if you go to that little shopping bag icon, you'll go to the Chrome Web Store. And if you do this in Dev Channel, you'll see the new UI where we have some of the newer packaged apps that our partners have been working on to get into the store. So we haven't put these live to everybody yet. Right now, it's only in Dev Channel on Windows and Chrome OS. But you can actually see what they'll look like. So let me just start off by showing you a couple of these apps. This is The Economist from FT Labs. So The Economist is a great example of an app that is a content consumption app for both online and offline. So obviously, the content has to come from somewhere. So when I'm online, I can go get the content. But you notice that here in the UI, it says available to read offline. So what has happened is this app, because it's a packaged app, and you can tell that there's no URL bar, right? There's no back, forward buttons, right? Why would you want that in an app? It has cached its data locally. So I can go and read stuff offline. If I make the UI a little bit bigger, you can also see that it's responsive. And the nice thing about this is because we have a rich windowing API, when I close the app and reopen it, it'll remember its Windows position, right? So these are some of the things. I'll talk about this throughout the session, but these are the kinds of things that you'll need to remember when you're building a packaged app. Because when you're an app, you now have control over the window. The browser no longer says, here's how big you are, right? You can control how big your window is. All right, let's take a look at another example. This is 500 pixels. How many people have heard of 500 pixels? Right. Oh, good. A good many of you. So 500 pixels is it's a professional photography discovery application, right? So professional photographers use this app to get their photos out there. And you can see, now I'm on my Pixel, right? So I'm using my finger to scroll through this. You can see nice touch responsiveness. Again, works just fine offline. If I kill the network connection, fire this app back up, it has cached the data locally, and I can look at whatever photos I had downloaded prior to losing the connection. OK, let me show one other example. And to do that, let me just jump out here really quick. Now, while this is starting up, this is a game called So Many Me. One of the questions I get from developers all the time is, I've got this existing code that I've built using, say, native client or Unity. In this case, this game actually was built, you can see right there, it was built with Unity. So this is an example of a loud application that was built using native client and Unity, and it's a game. It's actually a pretty great game, so I'm going to go ahead and start it. You can see that it's got some nice animations. Let me go ahead and skip through this part because I've already done that. But you see it's nice, smooth gameplay. right? You can see the little animated trees in the background. We've got some blurring effects going on there. So again, you can also see here at the top when I mouse over the window that it has this title bar that comes and goes, right? So again, another clue that it's an app, it's not a browser-based thing. But to be clear, all the stuff that you're seeing was built, with the exception of the game, in HTML5, right? HTML5, JavaScript, CSS, all of these are built using native web technologies. They just happen to be packaged up as applications, and because they're packaged up using Chrome packaged apps, they run on 4 runtimes just right out of the box, right? Mac, Windows, Linux, Chrome OS. And the plan, the vision that we have for this platform is that these apps will run wherever Chrome runs. So in the future, that means Android and iOS, and we're working with Adobe on the Cordova project to make that happen. Okay, so that's 6 runtimes. All right, let's talk a little bit about why you would want to do this. So why take a web app? Why build a packaged app out of it? So web apps are great, right? I come to praise web app, not to bury him, right? We all love web apps. They're all really useful. Web apps, they're great, right? Until they're not. There comes a point in time when web apps are decidedly not very great, right? We've all seen this, right? So there's offline cases. There's times when web apps just simply don't work very well. Games, right? Games on the web are awesome, right? Full keyboard, mouse input, games just rock until they don't, right? There's times when you're building a game and you want to be able to give your game players the same kind of experience that they would get if they were using a real gaming machine, right? So access to the USB, access to Bluetooth. You can't really do that on the open web, at least not today. So packaged apps solve a collection of problems that we've come to notice over the years at Google and also elsewhere in the industry. So first, packaged apps run offline by default. Okay? By virtue of packaging up all your assets and storing them locally on the machine, you just get offline access. Now that has some implications for app design that I'll talk about in a little bit. Packaged apps also give you access to the platform's capabilities and the platform's hardware. So for example, being able to store files in the file system, access the USB and Bluetooth, right? In the case of Chrome, because these are built on our platform, things like synchronizing data. You know how in Chrome, you set your bookmarks, and then we sync them, and you go to some other computer, and all your bookmarks are there, right? As a packaged app developer, you can also do that. You can take advantage of the same synchronization architecture that we do. Packaged apps give you a much richer, immersive user experience, right? I mean, you saw examples of this, right? There are just some applications where they don't benefit from back buttons and URL bars. They just get in the way, right? What does a back button mean in a game like So Many Me, right? So why not just package that up as a true app where the user is immersed in my experience? And finally, distribution. So distribution and updates take place via the Chrome Web Store. So when you package your app up, you put it in the Chrome Web Store, and now you make an edit to it, and now you want those updates pushed out to people. It takes advantage of the same update mechanism that we use. So every so often, we ping the server, say, hey, is there a new version of the app? If there is, it gets downloaded. You as a developer don't have to worry about that. You publish your updates, people get them. All right. So now that I've talked a little bit about what packaged apps are, why you might want to do them, let's start talking about what it takes to go from a web app to a packaged app. So the structure of a packaged app is actually pretty simple. In an existing web app, you have all your content, right? You have your HTML, your JavaScript, your CSS, and that's what you deliver from your server. And in the world of Chrome packaged apps, you continue to use that same structure. You build your HTML, your JavaScript, all the assets that you would normally use to build any other kind of app. All we do is put some infrastructure around that. Okay, so we add a manifest file that explains to the Chrome platform what the app is, what its name is, what version, what it can do, like permission-wise, so on. There's a background page and a main JavaScript file where you specify things like startup events, right? You listen for the app being launched and create your UI. And in fact, that background HTML page is actually optional. If all you do is have your logic in the JavaScript file, we'll just generate that for you. So really only two things you have to do on top of your existing app. So let me just take a quick, this is after all a developer conference. Let's take a look at some code. And all right, so let me switch over to my editor. All right, so here's an example. Can you guys read the code okay? Yeah, all right. So here's an example of a typical manifest file, right? It's just a set of JSON, and it explains things like, what the version of your app is, what its name is, things like that. So this gets packaged up as part of the packaging process to go to the Chrome Web Store. And the other part of it is this file right here. Now, the code that I'm showing you is for on our GitHub. We have that windowing API example. You'll notice that it's all just standard JavaScript. The only thing that we're doing differently is that we have these Chrome APIs that let you get richer access to the platform capabilities. And the philosophy that we've adopted is whenever the open web provides a capability, then we just use it, right? So file systems and so on. If it doesn't, and there's a need for something, then we'll fill that in with a Chrome API. But again, the driving vision is we'd like to standardize as much of this as we possibly can. So, all right, let's go back to the. OK. So let's take a look at some of those issues I brought up earlier, right? So offline by default. So again, just to reiterate, everything in your app, all the resources, the UI, right, your graphic assets, everything, that's all local. Right, that all gets installed when you install the app. And you install the app just like a user would install any other app. That's their experience is I'm just getting an app. Now, this has some implications, right? So first, you have to think about what the disconnected experience is going to be, including first run. I might download your app, right, run to the airport, get on a plane. I've got no connection. What's my first run experience? So you need to think about what kinds of features do you need to make available when you're offline, right? So not every feature may make sense offline. And in fact, if you think about some of the most cloud-connected applications that are out there today, like imagine, I don't know, a video conferencing app like Hangouts or something, right? Now, obviously, that doesn't work if you have no connection. So you need to be online for that. But there's no reason why when I'm offline, I couldn't do things like look at my contact lists, right, and see a call history and so on, right? So even in the case of the most connected apps, there's usually scenarios where things, can and should work offline. You need to consider the case of handling stale data, right, and synchronization. So the user's working in your app, they're offline, then they go online. Now what happens, right? That's an issue. And again, we store data locally. Now, there are certain parts of the web platform that we don't support for very good reasons. So for example, we don't support window.local storage. Anybody want to know why? Take a guess? It's synchronous, yes. Right, so synchronous APIs block the UX thread. So in cases where APIs are synchronous or are going to cause problems like that, we provide asynchronous counterparts for them instead. So in this particular case, you would use one of the Chrome APIs instead of local storage. So this means you have to plan for a great offline experience, right? Factor the app, figure out what you need to keep offline, do things that you would normally do, keep your JS separate from your HTML, right? Figure out what you want to make available offline. You can use web standard events like the online property and online-offline events to figure out when you are available, when you're connected to the web. Store data with things like Chrome Storage Local. In this case, it's an asynchronous API. You can use the HTML5 file system to do that. And in your manifest file, set the offline enabled flag. That way, in the Chrome Web Store, users can see, oh, this works offline, little treatment that we give it in the store. So here's an example of how you would store data using the Chrome Storage API, right? So let's suppose I've got some value in a form and I want to save that. Instead of using local storage, I would say Chrome Storage Local and then set And then that takes a whole set of key value pairs. And I have a function that gets called when the data has been stored. Right? So we've solved the synchronous problem in that case. Okay. In addition to offline by default, there's its counterpart, which is what we call cloud by default. So today, users increasingly expect that their data is going to just be everywhere that they are. And when you build packaged apps, right, users are they're going to have that expectation of your app. They're going to think to themselves, well, I want my data to be where I am. And again, we provide ways to do that. But this has implications, right? So they're going to expect things to sync. Your app is going to have to figure out how to handle things like conflicts. And you need to remember that your app might be used across multiple OSs and form factors. So we have a bunch of cloud features in the platform that you can use to take care of some of these things. So a few minutes ago, I talked about Chrome Storage Local. There's also Chrome Storage Sync. Chrome Storage Sync is pretty much the online synchronization part of storing data. So this is how, in our case, we synchronize bookmarks. If you want to synchronize things like preference settings or usernames or whatever other small pieces of data, you would use this API to do that. We also provide a synchronized file system API to synchronize larger pieces of data. So for example, if you have large files, like megabytes of data that you want to sync, this is how you would do that instead. Now today, the way that's architected is it uses Google Drive, but it's open. So in the future, we might support other backing stores, but out of the box, it's Google Drive. We also recently announced the Google Cloud Messaging architecture, right? The push messaging. So your server can send push messages down to your app. And because the Chrome packaged app system is local and running on the machine, your app doesn't have to be awake in order to receive them, right? The runtime will get the message, and the fact that you've registered a listener for a push message, your app will be woken up and told, hey, something has happened. And I'm sorry, it's 3 a.m., but somebody did something. We also have an identity API. One of the biggest problems or most confusing things that people run into is identity management and authentication. And so we've built an identity layer into the Chrome packaged app system to help handle this. So we have an API specifically for Google services. So when a user is signed into Google, and on Chromebooks they always are, they never see a login dialog. Right? If you call the Google version of that API, you'll just get the user's identity and you're off and running. And we have another one for third-party services. And so in the case of third parties, right, there's a whole dance that goes on, right? They get redirected to the app, they sign in, there's a redirect URL that goes back. So obviously it doesn't work in apps. So we built an API that does the same kind of thing, right? You take the redirect URL, you get the token, and you're good to go. So for example, the synchronized file system, right, you can control what the conflict resolution policy is. You can say, hey, the last write is the one that wins, or it can be manual, right? You can simply manage conflicts yourself. And all you do is request the file system, which is the same kind of API that you would use in the open web, right? You get a file system, an HTML5 file system back, and off you go. You just simply write your files. So for the identity case, I was talking before about the two different APIs, that's them right there. So getAuth token is the Google version, and the other one there, launch web auth flow, is the one for third parties. Again, so now today, those APIs, as of right now, are in experimental. So they're available in the Canary build and such, and the dev channel. You can't currently ship an application in the Chrome Web Store that uses experimental APIs, but we expect these to be hitting the stable channel relatively soon. All right, let's talk a little bit about user experience. So because these apps live outside the browser, and they can have richer experiences, right, richer user interfaces, there's some things that go along with that. So first, your app is responsible for things that it wasn't responsible before when it was back in the browser. Users have different expectations of how an app is going to behave versus a website, right? They just interact with them differently, so the expectations are slightly different. So how do you do this? You build a great user interface. Number one, we give you a rich windowing API to manage your app's windows. You can create windows, you can size them. There are all kinds of events available to figure out when they've been changed, when they've been moved, when they've been resized, and so on. You can do things like use the screen size to figure out what the initial size of your window should be. So when the app launches, you can say, hey, well, how big is my screen? Do some calculations, center your window, make it as big as you want. You should remember where the window is, right? When the user closes the app and then they come back to it again later, they're not going to be happy with the fact that you've recalculated everything. And the reason why they set the window the way they want it is because that's how they want their window, right? I mean, we've all done this, right? We get Sublime Text just the way we want it, right? And then we expect it to be there. So in a browser, obviously you can't do that. And users don't expect that, right? They expect the browser to remember how big it was. Your app is now responsible for things like that. You can do things like decide whether you want the operating system title bar. Now, in the apps I showed earlier in the demos, they didn't have the native title bars, right? They decided to hide them. So you can choose whether you want the title bar or not. If you don't want it, you still have to let the user drag your app around. I mean, that's just a basic capability. So we support the WebKit app region CSS property. And all you do is set that on the element that you want to act as whatever the title bar is, or the drag region. And we also give you methods inside the windowing API to do things like handle maximize, handle minimize, right? Figure out when you were open and closed, that kind of stuff. We also give you a way to do context menus. Again, this is an expectation that people have of apps, right? I control click or I right click, whatever it is. I expect a context menu to come up. You can do that in your apps. Okay, we give you that ability. All right. So I talked also a little bit about access to the platform and hardware. So you're able to get access to the platform via a bunch of different ways, right? Files, USB, Bluetooth. We have APIs for all of that. Sockets, right? You can just open raw sockets in your packaged app. So if you want to write the next great IRC client, you can now do that. This, of course, has implications. Anytime you give the user access to things like the hardware, right, security and privacy become even more important now. Right? Now it's not just cookies anymore. Now it's like, oh, I can discover devices around me, and I can get files, and I can open up raw just data sockets and start exchanging data with anybody I want. So it's important to remember that these issues they become paramount when you have these kinds of capabilities. I believe the wise prophet, Spider-Man's uncle, once said, with great power comes great responsibility, right? So remember that. So be clear to the user about when you're using platform resources. Now, in some cases, you have no choice, right? The camera comes on, the little light goes on, right? I'm on air. So in that case, the platform takes care of it for you. But you should be clear. Like, you should say, hey, here's how much data storage you've used out of this many bytes, right? Hey, I'm currently communicating over a connection with this other computer. Hey, I'm using the USB to do this gamepad. Or, hey, Bluetooth is currently enabled. Just give the user some indication of what's going on. And remember that in many cases, these are shared resources. So again, this is an example of where your app is responsible for something that in the past it wasn't, right? So you need to remember to release things when you're finished using them. All right, let's talk a little bit about application security. So how many people are familiar with the content security policy or have heard of it? All right, not many people, okay. So the content security policy is implemented inside Chrome packaged apps. And I'll show you a URL where you can go to learn more about this. Basically, it sets up a whole set of rules for what apps can and can't do. And we have a lot of rules that are intended to make applications a lot more trustworthy. We want these Chrome packaged apps to be thought of by users as really powerful, but at the same time, safe, like web pages are today, right? People feel safe. They go to their browsers, they click on links, right? They feel like they can do that without having to worry about their machine blowing up, whatever. We want packaged apps to have that same kind of trust that users have come to give web pages. So the first thing we do is we don't let you do things like eval, right? So don't be eval. We don't let you do things like use new function calls. All your JavaScript code has to be in separate JS files. Okay, you can't do things like inline event handlers and script blocks inside your HTML. That just doesn't work. You can't embed iframes. Right? We have a web view tag for that, and I'll talk about that in a little bit. But iframes are verboten. You need to declare where your content is coming from if it's not coming from your local app. So a great example of this is using Google Analytics. Right? How many people use analytics in their apps? A bunch of you, yeah. So that, by default, the content security policy will say, oh, you're trying to make a request to a domain that's not part of your local app here. And so by default, that won't work. So what you need to do is edit the content security policy for your application to say, I'm allowed to go and get data from this domain. And the experience that the user will get when they install the app from the Chrome Web Store will be, hey, here's what this app can do. Right? It can access data on this domain, and it can write files, and it can do all these other things. So it's a hint to the user of what's going on. So again, just to reiterate the point, so typically when you write a web page, you'll see code that looks like this, right? I've got my script block, my function, I have an event, says onload, do that. None of this is going to work. Okay, this is just simply not going to work. So what you need to do instead is put the code in an external file and then do things like get element by ID and whatever else, and add event handlers on the fly, right? That's a much better way of doing it. So to embed web content, this is, of course, one of the first questions that comes up. Well, then how do I do things like put stuff in a frame? We've actually built a web view tag to do this. So if you want to embed content in your application, you can use the web view tag. And the web view tag gives you the ability to do things like point at external URLs, and it gives you an event like, hey, I've finished loading the content. So that's how we solve that problem. For accessing remote resources, the only types of data that you are allowed to refer to that are not local to the machine in your apps are video and audio. So images have to be local, right? You can't say image tag and then path to some image on the internet, right? So if we go back to the example of the Economist, well, how are they doing that, right? Or 500 pixels, how are they doing that? What they do is you use XHR to fetch the resources from the remote location, store them in the local file system sandbox that you have, and that's without a permission, by the way. Your app has a local sandbox for files that you can just access to your heart's content, okay? So then once you've got that, you can refer to them like blob or data URLs. And in fact, this scenario comes up so frequently that we built a remote access loader library that will handle this for you. You simply you include the JavaScript code, you use the API, and you're good to go. So then, of course, the question comes up, well, what about templating libraries? Don't they use eval? Don't they use new function? And the answer is yes. So what do? Well, you can use libraries that precompile their templates, right? So handlebars, for example, right? You can precompile your templates. Other libraries do the same thing. So do that. The one escape hatch that you do have from pretty much everything I've said for the last 5 minutes, other than the doors over there on the side of the room, the one escape hatch that you have is that you can say, I want to run this particular page of my application in what's called a sandbox. So back in your manifest file, you can say, you know what, I want to be able to use eval, I want to be able to use new function, I want to be able to use some weird templating library that does all the things you're not supposed to do. You can declare that that page lives inside of a sandbox. And that page is then part of your application, but it's kept separate. Process-wise, it's kept separate. And then you can just use post message to communicate between that page and the rest of your app. Right? So that's how we solve that particular issue. All right. So I've got about 10 minutes left. I'm going to try and leave some time for questions, but let me sum up. So remember, offline, by default, right? Figure out what it is you want to make available. Keep all your stuff local. right? Identify what it is you want the user to be able to do. Cloud by default. We have a great set of APIs for working with cloud-connected apps, the sync file system, the sync architecture, the user experience, right? Your app controls all of that, right? Your app controls whether it wants to look native or look like something that people haven't seen before, how its windows behave, so on. Platform access, you can now have a real API for USB, for Bluetooth, all that great stuff. Security, remember, content security policy. It defines how your app behaves. Keep all your code separate and use sandbox pages for things that are not safe. So let me just jump over back to my Mac for a second. Okay, which has helpfully gone to sleep. Okay, so let's go back to the code. And let me go back. Actually, let me show you on our site, developer.chrome.com/apps. This is where we have all the documentation for how to build these. So if you have any questions about how the APIs work, we have all that documented here. We've also got a full list of the things that are native to the web platform that we don't support for one reason or another. So for example, plugins, right? Flash, etc. No plugins supported. No local storage, right? We don't do things like annoying alert and confirm dialogues. So all of that is gone. Yeah, some of these decisions we made for security reasons. Some of these decisions we made because, well, aesthetic reasons. The other thing I want to show you guys really quick. Oh yes, I'm running the canary, by the way. So that's bound to happen more than once. So these are the Chrome JavaScript APIs. So where the open web has you covered, that's great. For places where the open web APIs have not yet caught up or just don't make sense yet to have an open web API, this is where we come in and we give you the Chrome platform APIs. So this is where we provide capabilities like the windowing and supporting things like the dev tools. And remember, because these are Chrome packaged apps, because they're running on the Chrome platform, you get all the goodness of Chrome. How many people use the Chrome dev tools? All right, did you guys go to the Dev Tools Unleashed session that was just, yeah. So all of that awesome goodness that you get in the Chrome dev tools work here too. So while you're developing your app, you can bring up the dev tools, debug to your heart's delight, use all the great stuff that we give you in the dev tools. All the great stuff that comes in the Chrome platform, you get because you're in the Chrome packaged app. So let me just take a quick visit over to the Chrome Web Store. So this is the Chrome Web Store as it will look for you when you go there in the dev channel. Now this is on Chrome OS. Oh, actually, I should probably switch over to it, sorry. So this is how it will look. You can see that the existing hosted apps have been rebranded as websites, and the real packaged apps are now in the apps category. It actually has an apps category now. It never had one before. And this is where apps will be available to the user. The experience that the user will get is that when they go to install an app, right, if they don't have Chrome installed, we'll take care of putting the runtime on the machine for them. As far as they're concerned, it's a runtime. The app will show up in the launcher, right, like it does for any other app. And that's the experience that they will get. Has anyone used inline installation for extensions before? No? OK, a few people, yeah. So one of the features that we provide in the Chrome Web Store is a feature called inline installation. So just the same way that I can go to the store as a user and get an application, you as a developer can put a link on your website that will trigger the installation process inside Chrome. And then from that point out, the user gets the same experience that they would have gotten had they gone to the Chrome Web Store. So for example, if I choose to install an app, I'll get a little dialog that says, hey, you really want to install this thing? And here's how many stars it has. You can do the same thing so the user never has to leave your site. Right? It works today for extensions and the hosted apps, and we're going to support that for packaged apps as well. It's a really great distribution mechanism because it provides a nice continuity of flow, right, for users coming to your site. Okay. There's one last thing I want to show you guys before I take questions, and that is something that we've been working on. How many people have opened up their pixels and said, Now, how would I code on this thing? Yes, almost everybody. Now, today, we don't have a full-on local IDE. We're working on it. The dev tools can do some code editing. There's some great online editors, right? Cloud9, Nitrous, all those guys. We thought we might try our hand at providing an experience of what code editing might look like. Now, I want to be clear. I'm not about to announce any great product or anything, so that's, you put your phones away. And I'm not going to, What I am going to show you, though, is we as the team sat down and said, what kinds of things would an IDE need to do? And then let's see if we can do that. And this will teach us what kinds of capabilities we need to give the platform. And so down here, I've got an application called Code Editor. And it's called that because the developer who built it has had a ton of marketing training. That's what it does. So, all right, so this is it. This is the Code Editor project. By the way, this is on GitHub, and I'll show you the repo in a second. But the idea here basically is that you can see it's kind of got the Google-ish UI. And so when I create a project, right, I can create a new project, and I can call it, I don't know, Joe's Demo. And so I'll create that. And so when I do that, it fills out the skeleton for me of the packaged app, right? So you can see here, I mean, I know the font's kind of small, I'm sorry, but this is the manifest file that you're looking at right here. Here is the main startup JavaScript file, and you can see here it's creating a window, right? And you can see here it's following the practice I said before, figure out the screen height and so on. I've got things like what do you call it, code hinting. So if I say Chrome dot and then control space, right? And so pretty cool. And I've got this nice little tabbed interface. I can switch between my files. I can also just run this app. I should probably get rid of the error first, right? Here's the HTML file. Here's a graphic that I'm including in my app. And you can see that when I look at the graphic in the tool, it just shows you the image. So if I just run this, it will package it up on the fly, build it, and then run it, right? So I can do this edit, refresh, run cycle. And you can see it says, hello world. So I'll close that. I'll go back into the HTML, and I'll change that to say, hello IO. Don't need to save. We'll just run it again. Okay, that works. And so at some point, I'm going to be done with my app, and then I'm going to want to put it in the Chrome Web Store, right? So what do? I click Export, and it will export this whole project as a zip file, which then just goes right to the Chrome Web Store, right? So this is something that we're playing around with. The Google Chrome GitHub repo is right here. So if you want to help us out with any of this stuff, submit ideas, give us feedback, please do so. You can see here that we have the Chrome app samples. So all of the APIs that I showed you before have corresponding samples in the Chrome app samples repo here on GitHub. And that one, the aptly named Code Editor app is right here. And let me just go back. OK, so anyway, looks like I've got 2 minutes left. So if you have any questions, feel free to come to the mic and ask them. Otherwise, I will be up at the Chrome for Questions bar, hanging out there. I'll be here all day tomorrow as well. So if you have questions, please feel free to come ask. And that's it. Thank you, guys. Oh, we have a line.
Yes.
Great. Yeah.
Can I use AngularJS to build?
You can use Angular, yes.
Cool.
Yep.
Early on.
Oh, yeah. How embarrassing would that have been, right? Oh, there's this thing called CSP, and the Angular guys, yeah.
Early on, you joked that this wasn't the death of web apps, but then when you showed the new Chrome Web Store, it looks like it kind of is, because in order to be under the apps category, you have to be an installed app, and the rest of us will get relegated to be called a website?
Well, yeah, so we had to choose branding, and so we couldn't call, so the problem is things like the word hosted app doesn't really mean anything to anybody, and so we had to figure out, well, what do we call these new, well, these new things are apps, what do we call the old stuff? Before you rush the stage and just pummel me, just understand I did not make that decision. But yeah, so the future is that yes. So what was called hosted apps before will now live in the websites section. But they're still promoted. They're still there. It's
Does that reflect a direction that Google is heading, though? I mean, will all of the Google apps now end up being packaged apps only? And
Well, no. I mean, so we still support hosted apps. I mean, they're still supported. We just needed to make a clear distinction, and that's the way we went. Yeah. Yep.
Do you have any plans to do anything with like the top taskbar where you can like put an icon up there? Because sometimes it's more convenient instead of running it down and like on OS.
So and similarly like a system tray icon and things like that. Yeah. So yes, we've looked at these. It's right now we're driving towards a stable 1.0 release. So we want to get the platform right, and then once we've done that, we'll start looking at things like polish and other things we can do with systems and the stuff. So yeah.
Thanks.
Yep.
Can a Chrome packaged app use any of the Chrome extension APIs?
No, they can't use Chrome extension APIs. What we've tried to do is, in the case where an extension API made sense in the apps namespace, we decided to just make it available. We made an apps version of it. But again, security reasons and other reasons, you can't use extension APIs.
Okay.
Yeah.
Thank you.
All right. Other question? Yep.
For an app that's internal to our company, is there a way to do deployment through an internal web store?
Yeah, there is. Yeah, so we have the notion of an internal web store, and so for example, if you have a Google App account, you can do automatic provisioning. Yeah, so you can do stuff like that. Yeah.
You mentioned API support a socket.
Yes.
And what's the name of the endpoint? I couldn't find it.
I believe so. It might be in the trunk version of the docs. That's what's right here. It's the socket docs right here. Chrome.socket.
Chrome.socket?
Yeah, right here.
I
Oh,
don't
no, not right there. Hang on. Sorry. Right there. Yeah.
Okay, but it's not on the regular API.
If you go to, yeah, it's down in the list. It actually is in the stable docs. So if you scroll down the list, it should be listed there. Yeah.
Okay.
Yeah. Yes.
So if I want to download that IDE and run it on the Pixel, but
Yes.
I have to download it as a zip file from GitHub? And
Yeah, you can. So when you download a zip file onto the Pixel, so first of all, don't do this.
Okay.
The reason is because right now it requires the canary to run. We expect that will change as the API that we're using makes it into the dev channel. That will happen. So once that happens, you download it as a zip file onto your Pixel. The incredibly intuitive way that you unpack zip files on your Pixel is you go into the zip file, you select all the files, you do a Control-C, you go back to the file system, you do a Control-Paste. And that will unpack the zip file. I just saved you about 5 minutes of Googling, trust me, yes.
Okay, thanks.
Yeah.
Is there a way to package the Chrome apps with the Chrome browser installer for OSs which are not Chrome OS, Chromebook?
I'm sorry, is there a way to package apps
Like to package let's say I created a Chrome app.
Yes.
And now I want to distribute it not only on Chrome OS, but also on...
Well, it runs on all, so it runs on...
It runs on
Yes.
Chrome browser, but some
No, it
people
runs
don't-
on, no, you're not in the
have
browser
it.
anymore.
You don't
So,
need it?
no, this is, what we've done is we've taken the Chrome runtime, factored it out from the browser. So now this is any other runtime like Java or .NET or whatever, right? So you build your app, and as far as the user is concerned, they're just running an app on a runtime. So they don't know that they're using Chrome or...
So I'm getting an executable?
Yeah, so what we do is we package up what's called a CRX file in the Chrome Web Store. Yeah, so that's what gets installed onto the user system, and then when they launch it using
You can only run CRX if you're using a Chrome browser.
No, you're using the Chrome runtime. Let's separate out
Outside the scope of the
yes.
Chrome OS. So we're
Yes.
talking about Windows and Mac.
Windows, Mac, Linux, yes. Yes, it's the runtime will be installed for the user when they install the app if it's not already there. So, yeah. Right. Yes, right. Yeah, it's not a browser-based thing anymore. Yeah. All right, looks like I'm over. So anyway, any other questions? Please come find me upstairs.